When we are given an equation that we cannot intuitively solve just by looking at it, what we try to do is tweak the shape of it in order to bring it to a form that we can understand and that we can easily solve. Here, the first step on doing that is trying to take the right side and bring it to 0. So we want to bring every component to the left side. We would achieve this by subtracting 15 on every side and bringing it to a form that looks something like this. Minus 15 equals 0. This is basically the same thing as the first equation we had, but changed a little bit. We just changed the look of it. Now, if you have ever seen a quadratic polynomial before, then you know that it really looks like the standard formula, which is a times x squared plus b times x plus c equals 0. And you can see that those two are basically the same thing, with the difference that a corresponds to 4, b corresponds to, be careful here, we have plus and here we have minus, so it's minus 7, and c corresponds to minus 15. So you can take any equation that looks something like this and correspond it to these values, to these variables, basically. Why would we do that? We would do that because this form of equation is so popular in maths that we have developed a certain tool that help us tweak the form of this particular equation. It is so popular that we have developed an exact method that you just need to remember or just look it up. So what we call this tool is a discriminant, and it is symbolized with a delta, which is a Greek capital letter. Actually, let's make this a bit more red. Delta equals, and this is the formula we have developed. It's b squared minus 4 times a times c. Very standard. Don't let the letters scare you. What you do is take b corresponding to minus 7, a corresponding to 4, and c corresponding to minus 15. And if the equation was different, you would take the different numbers you have, and you will just replace them in the formula that you have just obtained. So b would be minus 7 squared minus 4 times a, which is 4, times c, which is minus 15. And if you place this in your calculator, you would get 299. It's basic arithmetic, nothing to scare you here. But obviously 289 is not your solution. And the way you will find your solution is one small extra step, which is another formula. Again, basic arithmetics. Don't let it scare you. It's minus b plus minus, because we have two solutions, so one would be plus and one would be minus, the square root of what we just found of our discriminant, divided by 2 times a. Now, I know this looks a little bit scary, but it's basically the same thing. We take b, we replace the number, we take delta, we replace the number, and a, and we replace the number. B is minus 7, we have minus on the front, so it would be plus 7. And then we have plus or minus the square root. If you place this in your calculator, you will find the square of 289 is 17, divided by 2 times 4, which is 8. So what we get is x equals 7 plus 17 divided by 8, or x equals 7 minus 17 divided by 8. And that would be 24 divided by 8, which is 3. And that would be 10 minus 10 divided by 8 would be minus 1.25. And basically you have your solutions. You don't need to do anything else. It's maybe very straightforward if you understand that this is not something that should scare you. It is something it's basic arithmetics. You have a standard method that you use that you just need to look up or just remember. And the only thing that changes every time you solve an equation is A, B, and C, the values that correspond to that. And what we mean when we say tweaking an equation and bringing it to a form that we can understand, you can take these values and say x equals 3 and x equals minus 1.25, and you can tweak it a little bit and say, okay, I can write it like x minus 3 equals 0, or x plus 1.25 equals 0. And what is nice about this is that when we have a product x times y equals 0, then the only way that this product would equal it is 0 is if x equals 0 or y equals 0. And this goes both ways. So if x equals 0 or y equals 0, then we have the product equaling 0. So we can take those two and make a product of them. X. Okay. And the fun thing is, if we multiply 1 by 1 here and here, we will get the initial equation we had and then multiply with 4 because to make it look even more similar, minus 7x plus 0. Okay, so if you do all those calculations and then multiply with 4, you will get the initial equation that you tried to solve, and this is because those two are the solutions. And this this entire process shows us that this formula really does hold up and really does work. And if you try it with any quadratic equation of this form, you will see that it really does hold up. And this is our explanation.